Good evening, everyone, and welcome back once again to our weekly YouTube series where we discuss about the various different projects which have been done by our data specialists. Today, we are going to be looking at a very interesting project where we will focus on the manufacturing industry and the manufacturing and supply chain logistics domain. Okay. So joining us today, we have Pawan. Hi, Pawan. Good evening.
Yeah, good evening, Aditya, and good evening, everyone.
So, Pawan, why don't you go ahead and just give us an explanation for this project?
Yeah, sure, Aditya. I'm really excited about this. First of all, to begin with, let's talk about the business problem. Nowadays, the steel pipes industry faces significant challenges in efficiently managing inventory levels. Demand for steel pipe fluctuations due to various factors such as we can say market trends, construction projects, and seasonal variations. These fluctuations often leads to two major issues. One is stockouts, and we can say another one is excess inventory. Stockouts occur when we ran out of stock, leading to missed sales opportunities and potential revenue loss. On the other hand, excess inventory means we are holding more stock than necessary, which increases carrying costs and require more storage space. Both scenarios negatively impact the business either through lost sales or increased expenses. So here we can see that our primary objective is to minimize those stockouts and excess inventory. By accurately forecasting demand, we aim to ensure that we have the right amount of inventory at the right time also. So now coming to the constraints, one of the key constraints we need to consider here is maximizing customer satisfaction. This means ensuring that our products are always available when customer needs them without overstocking. And in business success criteria to measure our success, we have set specific business criteria. Our goal is to achieve at least 20% reduction in stockouts and excess inventory. This would significantly improve our cost, our inventory management efficiency, and reduce associated costs. And from a machine learning perspective, our success criteria is to achieve an accuracy of at least 80% in our demand forecasting models. So this level of accuracy is crucial to making reliable prediction that the business can depend on. Finally, in terms of economic success, we aim to increase revenue by capturing potential sales opportunities through improved inventory availability. Our target is to boost sales by around 10%. By having the right products available at the right time, we can meet customer demand more efficiently and enhance our revenue. This is about the entire project, Aditya.
Hmm. Right. So thank you so much for setting the context as to what exactly we mean by the steel pipe inventory forecasting. Now, what are we going to take a look at next is actually move towards a bit of our technical understanding. For example, we have our model architecture. So again, we'll be pointing towards Pawan since he is the one who has worked on this. Like, you just explain this for us, Pawan.
Yeah, sure. As you can see here, this is the entire architecture we done in that project. First of all, we receive data from a client. Our client is one of the leading companies, so we received the data from their database. Later, we store the data in our database to secure the data. Later, we used some coding techniques to perform data pre-processing techniques. After that, by using this cleaned data, we performed model building. Means we are using so many models here to find the best results. So in that models, we find the best model by using some performance matrix like MAPE value. After that, by using this best model, we done deployment using a web framework called Streamlit. First of all, we done it in locally. After that, we moved into a global one AWS. In AWS cloud, we deployed it in again. After that, we gave the all the credentials to the user, so they can view all the results, forecasting results by themselves only. So like this, we performed entire process, Aditya.
Hmm. And of course, everybody should would be very interested to know about the various different models that we have tried. So these are some of the models, and we are seeing the results. So again, what is this 9.5238 and 12.06 Pawan?
Yeah. In this project, we experimented with several advanced forecasting models to find the best approach for our needs. These are some of the models we used in our project: Ensemble model, LSTM, Prophet, AutoArima model, and Sarimax model. We know that Ensemble model combines predictions from multiple models for improved accuracy. And also, LSTM is a recurrent neural network that capture long-term patterns in time series data. And another one is Profit, developed by Facebook, handles seasonality and trends effectively. Like this, these are the models used for various scenarios. Finally, to compare the performance, we used the mean absolute performance metric, that is MAPE. We can see here. Lower MAPE indicates the best accuracy. As you can see here, the ensemble model achieved the lowest MAPE, that is 9.5238. So making it is the most accurate for our forecasting needs. This helps us to manage inventory better and meet customer demand efficiently. Yeah, that's it, Aditya.
Okay. And finally, the final question is the results. So again, it's very important. This is the output that the client will see. So sure that when you were sharing this with the client, you would have explained it to them. So do you mind giving the same explanation to us?
Yeah, sure. Yeah, like I said, we deployed it in using a web framework called Streamlit. As you can see, this is the entire UI here. On the left side, we provided so many options there. The top one is, we can say, browse files, so they can upload their data here. After that, we can see so many options there. The first one is pipes forecasting and states forecasting. In this, the customer wants two types of forecasting. One is the entire pipes forecasting. Here we are not considering any state level wise, but we done another forecasting also, that is state level wise. For this particular state, for this particular pipe, how many forecasting values will come. Like that also we perform. Later one, select type. Select types means, as we all know, pipes contain so many types: square type, rectangular type. Like that, there are so many types are there. So to separate those, we created one option there, separate. So they can select a square, rectangular, and other pipes also at the same time. Later that, select pipes. Here they can select the pipes, and below that they can select the state also. In that particular pipe, state will be available. And below that, last one is forecast period. In that, they can select some certain months forecasting periods. So they can see the forecasting values of 2 months, 3 months, and maximum of 4 months. And right side, you can see the graph there. And below, you can see the table, final forecast values along with their lower bound and upper bound also we can see there. Like that, the result will appear, and we can select multiple options at the same time. Like we can select multiple states at the same time, and we can download the multiple state results at the same time also. This is the entire UI.
All right. So there we have it, everyone. Thank you so much, Pawan, for this detailed explanation of the project. And finally, guys, do follow us on our social media platforms across Instagram, YouTube, and LinkedIn for further such content. Thank you so much from everyone here at 360 Digit MG, and we hope to see you guys next week. Goodbye.